Hey guys, welcome back. Today we're going to take a look at blueprints and C++ in Unreal Engine 5 and discuss why the Hub World MMO example project uses a mixture of blueprints and C++ instead of the mostly BP route we took in the Let's Make an MMO in UE4 tutorial series. Let's get started. What about BP nodes? A BP node either calls a C++ method or calls other BP nodes that call C++ methods. In the end, blueprints are always calling underlying C++. If a BP node doesn't exist to do what you need, and it can't be done with a combination of other blueprint nodes, then you're just out of luck. You can hope someone makes a plugin, but there's nothing you can do about it if they don't. Many of the properties and functions in Unreal Engine 5 have not been exposed to blueprints. This means that when you're looking at the properties on something like, say, a character, you might be looking at 90% of what's there, but you're not looking at everything that's there. They expose what most people need, but a lot of times there's some extra things that are not exposed to blueprints, and sometimes you do need access to those. Some systems in Unreal Engine 5 are completely or partially hidden from blueprints. Animation update rate optimizations is one of those systems that's hidden. It's pretty useful. Game playability system, parts of it are hidden from blueprint. Just depends on what you're doing, what kind of game you're making. What we've found is that persistent world multiplayer games, they often require some C++. You can't get access to everything you need in Blueprint. Blueprints are binary U assets. This means they cannot be merged with source control. This is very problematic in large teams. With text-based code, if one programmer is working on the file and another programmer is working on the same file, when you get done, you can merge the two together. Either they worked on different sections of the code and it just auto merges with no human intervention, or they worked on the same lines of code and then you see one programmer's work on the one side, one programmer's work on the other side, and you can work out the differences. But because blueprints are binary, there's no text, there's nothing you can see, you would just see a list of ones and zeros, there's no way to merge two different changes. What this means is that you have to work under a type of source control system where a file has to be locked and two people cannot work on it at once. The other problem with this is in code review. If you've ever worked at a programming shop, one of the important parts of computer programming is doing code reviews. What this means is that when changes are pushed to source control, either your colleagues or maybe a manager, a DevOps person, they're going to review the changes you made to make sure that you didn't make any mistakes. This is very important. Unfortunately, because blueprints are binary U assets, you can't tell what changed, right? And so this makes it very difficult to do code reviews, and it makes it hard to work on blueprints in a large team. The other problem is that blueprints have hard references to dependency. So you've probably run into this sometimes where you have a blueprint, maybe it's built off one of your C++ classes, and the C++ class changes slightly, and maybe something was renamed, and now the blueprint won't even open. You're stuck. You can't open the blueprint. You can't fix it. Even if you opened the U asset and fixed it, it's binary. It has a checksum on it. There's nothing you can do. It can't be fixed. And the other problem might be that maybe other blueprints it relied on moved, and you had a problem with the redirectors that it creates, or there was some type of thing. You end up with corrupt blueprints. They won't open, and they can't be easily fixed. So that's another problem with blueprints and their hard references. The next problem is scalability. A million lines of C++ code is actually not that difficult to manage. I've worked on many projects that had far more than a million lines of code. It's not a big deal. But can you imagine managing 1 million blueprint nodes? It starts to become unwieldy. And so we wouldn't want to deal with a million blueprint nodes. We would want to work with a much smaller number than that. So does this mean blueprints are bad? Absolutely not. Absolutely not. Unreal Engine 5 was designed to build your games using a combination of C++ and blueprints. They both have their purposes. You always want to use a mix of both. That's the way the engine was designed to work. You have game programmers through the C++, you have game designers who take that functionality and with blueprints turn it into a game. This is the pattern we want to follow. So the pattern that I follow is to build functionality in C++ and then configure and orchestrate that functionality with blueprints. Where that line is could be different for each team, each game. You're going to have to kind of find that on your own. But in the Hub World MMO example project, we will be using a mixture of the two. And I'll talk at various points about why we put something in C++ or why we handled something in Blueprint when that comes about. Okay, so let's talk a little bit about C++. We're going to go through and look at the setup of the project in the Hub World MMO. But first, I want to talk about H files and CPP files, because if you haven't worked with C++ before, this is something that a lot of other languages just do for you automatically. But in C++, you have to manually manage your header files. So C++ header files have an .h extension. They're primarily used to declare what is in your C++ class. And so they usually don't have code itself in them, functionality, but they say, hey, here's what my class does have, right? Here's what I have. And so this is a way of telling some other code file, some other class, hey, that class over there, this is what it has. This is kind of like its blueprint of what's in it. And then C++ code files have a CPP extension, .cpp, and they're primarily used to define the method. So in the header file, we say, hey, we have a method called this, or we have a class called this. But then in the CPP files, we say, yeah, and here's what that does, right? And so they usually come in pairs. Okay, Unreal Engine class naming conventions. So Epic has some very important naming conventions, and they are not all optional. Some of them are required, or your classes won't build. So we got class name prefixes. A is for actor. Some examples are A supply pod, A HW gas player character. The HW in this case is Hub World. You'll see that appear a lot in the Hub World MMO code. But the A in front of it is for actor. U is for U object. So we have U HW player anim instance. A lot of times people ask, what's the difference between an actor and a U object? The primary difference between the two is that an actor can be placed in the world. A U object cannot. What this means is that the actor has a transformation. It has a location, a rotation, and a scale. T is for template, things like T array or T shared reference. I is for abstract interface. We have an example in the Hub World MMO project called I interactable. It's an interface. And then F is for structs or other classes that don't fall into the above. And an example is FHW base character stats, which is a structure for holding our base character stats. Now, we don't include the class name prefix in the file name for the H and CPP files. This can be a little bit confusing, but let's say we have a HW gas player character. We would omit the A when we name the files, and so they would just be named HW gas player character. So these one-letter class name prefixes, they're not included in the file names. There are also variable name prefixes as well, such as E for enum. And then there's also the convention to use a lowercase b for booleans, such as the variable where you set replication called replicates. It's actually b replicates. And when you use this in C++ and it goes to blueprints, blueprints are actually smart enough to omit that b from the name. So what you see as replicates as a checkbox, say in the blueprints, it's actually behind the scenes, it's b replicates. The Unreal Header tool requires many of these prefixes to work properly. Not all of them, but there's some of them, if you get this wrong, it won't work. Let's talk about the Unreal Header tool. Unreal Engine uses a pre-parser in front of compiling in C++. So what happens is that before your code's compiled, the Unreal Header tool parses your C++ headers and generates code. Right. So when you're compiling your code, you're not just compiling your code. You're first having your header file scanned by the Unreal Header tool. It generates some extra code. Then it compiles your code plus the extra code that it generated. And you'll notice this in your header files. You often have another header of the same name, but it has .generated.h. So that's where that comes from. That gets generated in the background by this Unreal Header tool. When you press build, runs it automatically. The Unreal header tool requires metadata, not to be confused with C++ macros, which look similar. These aren't C++ macros. They're metadata that the Unreal header tool is going to look for and use to generate code. Some common ones are uClass, uStruct, uProperty, uFunction, and many, many more. As I mentioned before, your class.generated.h files are output from the Unreal header tool, and then the C++ code is compiled. Let's take a look at the structure of Unreal Engine classes. So the first thing we want to take a look at is that there is an optional API metadata specifier for making this class exportable to be used in other modules. This is usually optional for our game project code. Obviously, if you're making plugins where something needs to use something in a different module, you're definitely going to need to do that. If your game is potentially using multiple modules, maybe you're using a modular plugin approach to building your game, then you're going to need this API metadata specifier to make those visible to other modules. If you're putting everything in one module in your game, nothing needs to be visible from anywhere else. This isn't required. I do believe that at this time, if you use the wizard, class generator, whatever it is in the editor, I believe it is adding the API metadata specifier. Then there's additional things like generated body, generated uClass body, generated uStruct body. These are where it's going to insert additional code into your headers to be able to power the UObject system that Blueprints is built on top of. You'll also notice that there is a public, protected, and private section. These are optional, so they may not all exist in every class, but it basically tells us when other classes look at this, what can they see and what can they call. Public means that any other class can see it and call it. Protected means that only classes that inherit from this class can see it and call it. And private means only this class can call it, not even classes that inherit from this. So it'll be invisible to classes that inherit from this. Two other common metadata specifiers in our Unreal Engine classes are uProperties and uFunctions. These also, usually in parentheses, they have various things like blueprint read write, blueprint callable, things like that, that primarily tell us how they're going to function in blueprints. How are the blueprints going to see this, and what are they going to do with it? Of course, if it doesn't have that uProperty or uFunction, it's going to be invisible from the blueprint system. So as we're building stuff out, we have to think about what does Blueprint need to see, what do we need to call, what might be internal to C++ only, and what might we need to expose to blueprints, and we'll mark those correctly with uProperty and uFunction. Let's take a look at the Hub World MMO project layout. First, you can see that we have three main folders: config, plugins, and source. Our config folder has INI files, and you'll see that default game INI is one that we often have to work with for OWS. And then you'll see under plugins, we have the OWS plugin. And then source folders is where we have our game code. You'll also notice that source code is split between public and private folders. The public folders contain our header files, and the private folders contain our CPP files. You'll notice that below those, we have used subfolders to organize by category. This doesn't do anything special. It just allows us to more easily find what we're looking for and understand what systems these different code files relate to. Now let's take a look at what some of our folders look like when we open the editor and take a look at our blueprints. We have an _HW assets folder. This folder comes from our Hub World MMO staging project. We will be taking a look in a future video at staging projects, the importance of having them, how they work, how to organize your dependencies properly before you move things into your main project. And so basically in this case, nothing comes directly into our main project. Everything goes into the staging project first, gets all the dependencies worked out, gets everything set up correctly, and then gets put in that underscore HW assets folder and then migrated over into our main project. The Megascans and MS presets folders are part of the Megascan system, and they're also getting added to the staging project, getting cleaned up there, getting everything figured out, and then moved over to our main project. Beyond that, we have an ability system folder and a BP folder. And basically, the ability system is anything related to the gameplay ability system. And then the blueprint folders is additional blueprints needed by our game. And we'll categorize those based on the system that they're related to below that. Now let's take a look at how to debug in C++ with Visual Studio. The first thing we need to make sure is that when we want to debug, that we are using Debug Game Editor and not Development Editor. Let me tell you why this is important. So when you use Development Editor, C++ is running various optimizations that modify your code to the point of removing your code from the system. And so what this means is that when you go and try to step through your code, it will not be able to step through it because the code you wrote may not even have ended up in the final compiled product because it was optimized out. And so this will make it very difficult to step through. You often see people saying, I don't understand why this debugging is not working. It's not showing me this value. It's skipping this code. It's a real mess. And so what you have to do is you have to debug with Debug Game Editor. What this does is that it says, no, don't turn on those optimizations. So keep in mind, when you're running Debug Game Editor, it could run slower. But it's saying we're going to keep all your code as you wrote it so that we can step through it as is. And when you're in Debug Game Editor mode, you can hover over things, inspect the values, and you're going to get a true value. You're not going to get the bogus whatever it shows in Development Editor. I have an important reminder when it comes to Debug Game Editor because I make this mistake all the time, and I want to make sure you guys don't make this mistake. So when you compile for Debug Game Editor, that is not visible when you run from the U project. So if we were to make some changes to the code, use Debug Game Editor because we're debugging in C++, and then later you go and double click the U project file, it will not pick up your changes. So you do have to make sure that after you're done debugging with Debug Game Editor, you switch it back to Development Editor and build it at least once. Then the U project can see that. Otherwise, when you start from the U project, it doesn't even know that the Debug Game Editor files exist. It only knows about the Development Editor files. Let's also take a look at how to do breakpoints. Breakpoints are very important because you can set a breakpoint where you want it to hit, and when the code runs through and it hits that line, it'll stop, right? And that lets us then step through at that point or inspect a value at that point. And so we'll also take a look here at how to inspect values. Let's step through debugging the login and create session API. So in our OWS login widget, I've added a breakpoint by clicking here to the left in login and create session. And then I've also added another breakpoint in on login and create session response received. This is the asynchronous callback where it'll come back with the result. Now let's start up the project and give it a try. We're on the login map and we have the net mode set to play as standalone. I've also put a breakpoint in the OWS project in the C# on login and create session so that we can step through all the way to the API as well. Let's start the game. Okay, it hit the breakpoint. So we can hover over here and we can see dart7@test.com is the email. And the password is 123456789, right? So it called this C++, and we're now able to step through it. If we go back up to the debug menu here, you'll see that our options are step over F10 and step into F11. So F10 steps to the next line without going into any additional functions. Step into actually goes into those functions. So we're going to press F10. And we're going to press F10 again. We're going to press F10 again. We can see that the post parameters here. We can click on this magnifying glass to see them better. This is what's getting sent. This is the JSON, right? This is what's going to get sent. And if we stepped into, so now we're going to press F11 to step into post OWS2 process OWS2 post request. And you can see it goes into this next function. We're stepping through it. And then when we get to the end of it, it'll go back. See, there we go back. Okay. Now we're going to click continue. And it hit the C#. This is now the OWS project, not the Hub World MMO project, right? And so now we can go here and we can hover over this request and we can see, hey, look, here's what it sent into it. Our email and our password. This customer GUID's empty at this point. It gets filled later. It's actually sitting right here. See, there's the customer GUID. It's not part of the request object. It actually comes in on a header. Hit F10. We could step into this to handle it. So we could hit 11, jump in here. Okay, it's going to call this. It's going to call the stored procedure that calls the database. I guess it's not a stored procedure anymore. It's going to call the SQL that calls the database. And we can see what the output of that is. Authenticated equals false. So it's going to return username or password is invalid. That was not the correct username and password. And so at this point, I'm just going to hit continue. And it's going to come back here. So this was the asynchronous callback, right? And if we come through here, we can go and follow through. It's going to take that JSON object. It hasn't filled it yet. Okay, here we go. We're going to look at the error message. Okay, response is unsuccessful or invalid. What probably happened here is that we waited too long stepping through it. So we're going to do this again real quick, but we're going to do it. We're going to do it faster. Yep, login response invalid. So here's what we're going to do. We're going to go back over to the OWS2. And we're going to close this. And we're going to remove this breakpoint so that we don't time out the request from how long we were waiting. And we're going to basically run through the exact same thing again. Hit login. I'm going to drop this breakpoint, hit continue. It comes back. Okay, and we're stepping through. Here's the JSON object. It has our value here. See, authenticated equals false. Username or password is invalid. Here we check the error message, and we're going back. We're hitting, this goes back as error login and create session, and sends that error message. Username or password is invalid. We hit continue. And there it is. Username and password is invalid. So we've stepped all the way through the process. That's how we debug. This is how you can find issues with things and fix them. This is super important. As programmers, we probably spend 70-80% of our time debugging. Things never work the first time. So that's how you do it. If you have any questions related to this video, please leave your questions in the comments section. The Open World Server and Hub World MMO Discord link is in the video description if you want to discuss something in this video further. Like and subscribe to be notified of future videos and to help with the algorithm. Until next time, have a good one.